Welcome everyone, this is another Chris Course with your host Chris, and today we're going to be developing a Mario type side-scroller like game. So this is exactly what we're going to be developing, is we're going to create this nice little background with a character that runs side to side. We can go backwards if we'd like, we can jump over these little gaps in the course, and eventually, if we mess up, you're going to see things restart and we go back to the beginning. We're going to be developing all of this with pure JavaScript. I think we're only going to be using one library. We might not even use any at all, but this is what we'll be developing in this tutorial. And if you'd like to take this further, I'm coming out with a premium course on this topic, which will teach you how to do things such as create power-ups, shoot fireballs, jump on Goombas, create enemies, and even slide down a flag at the end of the course. Nevertheless, everything you're going to learn in this video is exactly what you need to get started with creating this kind of game with just pure JavaScript, no frameworks or anything like that. So how do we get started with this? Well, let's go ahead and check out our checklist. So the first thing we're going to need to do is set up our project, create all the files as necessary. Then we're going to need to create a player. You'll see we have one right here. We're going to need to add gravity, which brings our player down to the ground. You'll see if I jump, gravity automatically brings him down to the ground. And then we're going to need to add some player movement, be able to move side to side like we see right here. We're going to need to create these platforms, which we can jump on, and we're going to create a rudimentary platform before we create these image-based platforms. We're going to need to scroll the background, so as we move side to side, you'll see the background is actually moving, not our player. That's the whole concept and the whole magic behind a side-scroller game like we see right here. Once we do that, we're going to need to add some sort of win scenario. We're just going to add some console log text here to start, make it really easy once we reach a specific platform. We're going to be adding in image platforms, add some parallax scroll, death pits, and then finally we're going to be creating the full level and fine-tuning things to create exactly what we see right here. So let's go ahead, enough talk, let's get started. So the first thing we're going to do is set up our project. Easy enough. We need to create the folders and files in order to get this working. So how do I do that personally? What I like doing is I like going inside of my Finder, finding a folder in which I store all my web projects, which is going to be this right here. And then I like scrolling down until I have a little bit of room at the bottom. I can right click and click new folder. You can also press Command Shift N to create this new folder. And I'm going to call this Mario-Game. So up here, I have my folder created, and now I can drag this folder on the text editor of my choice. I like using Sublime Text. I'm just going to drag that on top, and now you see we have this folder open, so I can get rid of Finder for the time being, and now I need to create a new file. I can just create this file by typing inside of this open empty text editor, hitting Command S, and that is going to ask me to save this file as what? Well, I want to save this as index.html because we always need an index.html file before we can actually code anything related to web development. So we just want to make sure that we store this inside of our web Mario game directory that we just created. And then I can go ahead and hit save. So I'm just going to go ahead, hit Command S one more time to make sure this is definitely saved, but you'll see now we have index.html within our Mario game folder. We need one other type of file. What is that file? Well, it's going to be index.js. This is where we're going to write all the code to get all this stuff working within our game. So how do we go ahead and create that file within Sublime Text? Well, what I like doing is hitting Command N to open up a new tab, and then here I can hit Command S and call this index.js. This is going to be our JavaScript file. So now to set up a canvas element within our project, what we want to do is we want to go ahead and create a canvas tag like so. So I'm going to go ahead and add this canvas tag, and now I actually want to see what this looks like within our browser. So if I want to do that, I'll right click, hit reveal in Finder, and then I can double click on index.html, and this is what our project looks like so far. Doesn't look like anything's there, but if we inspect, you'll see inside of body we have our canvas element. So great, we know it's being read correctly by the browser. But now we need to start accessing our canvas with HTML canvas. So how do we do that with JavaScript? Well, we're going to go ahead and create a constant called canvas. In this, we want to go ahead and access our document and call query selector, which is going to allow us to select a specific HTML element. We want to select the canvas element. That's really the only one we have within our document right now. We can go ahead and test that this works by console logging out canvas right beneath where we grabbed our canvas element. So if I go ahead and refresh and look in our console, not going to see anything. That's because when setting up our project, we need to make sure this index.html file references this index.js file. So how do we do that? We simply create a script tag, and then we want to reference the source of the file we want to reference. This is going to be no other than index.js. So on refresh now, you'll see we're console logging out our canvas element, but within JavaScript. Our first line of code works. How great is that? Well, next we want to go ahead and access our context, and this is going to come from our canvas element. So we can go ahead and call our canvas element right here, and then we're going to say get context. What kind of context do we want? Well, we're going to be creating a 2D game, so we're going to put in the argument right here a string that says 2D. And now we can console log out this C context, and I just like calling this C for short because I know I'm going to be using this all over the place, but just know this stands for context. If I console log this out, we have our canvas context in place. So that's really all we need to do in order to set up our game. So if we go back to our to-do list, we can go ahead and mark off project setup. Done. Easy enough. Okay, let's move on to player creations. How do we create a player? Well, to create any sort of player or artwork on the canvas, what I like doing is creating a class, a JavaScript ES6 class. So how do I create one of those? Well, I'm simply going to type class, and I'm going to call this player, uppercase P, because whenever you create a class, it's standard convention to uppercase the first letter. So we're going to create a class of player, and this just takes an opening and closing curly bracket. And now inside of here, we can begin adding properties that define our player. So what are some properties that are going to define our player? Well, before we actually define these properties, we need to create what's known as a class constructor method. So whenever we create a player, this method right here is going to be fired, and it's going to set all the properties associated with our player. So we just need to make sure that we include this before we actually create and set those properties. So what properties do we want to set associated with a player? Well, to start, let's go ahead and make our player just a standard square. What properties does a square have if we were to draw it on our canvas? Well, our square is going to have an X position, a Y position, a width, a height, and maybe even a color in which we can change based on what we wish to change it to. So first thing first, we need to go ahead and say that our player is going to have a position associated with it. And I like setting this equal to an empty object, well, not an empty object, but an object that contains an X and a Y position. So if I were to go ahead and say our default position is going to be 100 and our Y position is going to be 100 by default, if we were to create our player, it would be placed somewhere over here on the canvas. Another property our player is going to have is going to be its width. We can set this equal to 100 to start. It's going to have a height, because we need a width and a height to create some sort of square-like object. And then this is going to have, should we put a color here? It doesn't really matter for the color. So we can just go ahead and start off with position, width, and height for our constructor element. And then we need to define what a player actually looks like. So to start, we're just going to create a basic square. And I'm going to create an arbitrarily named method inside of our player class called draw. This can be called anything you want, but since this method is supposed to define what our player actually looks like when we draw it on the screen, it makes sense to call it draw. So how do we actually draw out a player using canvas? Well, to draw out our player with a square, what I'm going to do is I'm going to select our canvas context, our C, and then I'm going to access its fill rect method. And you'll see right here, this takes a few arguments, an X, a Y, a width, and a height. So where do we want our player to be drawn? Well, wherever the player's position, specifically its X position, is. Where do we want the Y position to be? Well, wherever this dot position dot Y is. So we're just referencing this right here within our constructor, and then we're going to reference this dot width, so 100, and then this dot height. And fill rect should be able to draw a rectangle with a black color by default, so we don't need to specify any color just yet. But now we have pretty much everything we need to begin creating and implementing this player class. So how do we actually implement this player class? Well, we can go ahead and create a const called player, and this is going to be equal to a new player object. We don't have to pass through any arguments just yet because we set all of our properties to default values. So we can just go ahead and save that. And then we need to make sure that we actually call this draw method on our newly created player. So we can just go ahead and call draw, save, and refresh. And now you'll see that our player is being drawn on the screen. So one issue here is you'll notice this isn't a square even though we define our width and height to be equal to 100. If I go ahead and inspect our canvas, you'll see our canvas just isn't the correct size. It needs to go ahead and take up the full screen, at least for the time being. So let's go ahead and make sure that our canvas element takes up the full screen. So you can go ahead and do this within CSS. I always like doing it within JavaScript because I always end up changing this later on or having it be affected by the code in some way. So in order to change the canvas size with JavaScript, I'm simply going to reference our canvas element, get its width. What am I going to set this equal to? Well, our windows dot inner width, so the full width of our browser window from left to right. Now, one cool thing is whenever you reference a window object like so, you don't actually need the window dot in there. You can just reference inner width and it's going to give you the exact value you need. You might lose a little bit of code clarity because window isn't going to be there, but if you've done this enough, well, you know that inner width is always going to be referenced from window, so we don't need the window dot. We can just go ahead and get rid of it, clean up our code a little bit if you're more advanced. So by setting our canvas width equal to inner width, you'll see our canvas takes up the full width of the screen. Let's go ahead and do the same thing for our canvas height. So I'm just going to go ahead and copy this line of code, reference our canvas height, and set it equal to our windows inner height, the full height of our window object. So now we can see our full player, but we do have one issue here still, is we have this little bit of margin on the left and top hand side of our canvas element. How do we get rid of that? Why is it even there? Well, that margin is there because browsers provide some defaults to certain elements on the screen. You'll see if I select our body right here, we have this orange edge around our canvas. This means we have margin there by default. We want to get rid of this. So what we can do is we can go back to index.html, create a style tag, and here we can reference our body element and say we don't want any margin, so we're going to give this a CSS style of margin 0. So now on save and refresh, you'll see that margin is taken away, and now our canvas element is definitely taking up the full width and height of our screen. And you might have to refresh if you move things around to make sure that it takes up that full width and height. But we have our player over here looking pretty good. But we might want to change its color. Let's just go ahead and make this red to really make this stand out. And we're also going to make sure that our player is a little smaller because he's kind of big right now at 100, 100. So what I'm going to do is I'm going to change our width and height to something smaller, like 30. That looks good to me for a starting player. And then I just want to go ahead and make this red. So within our draw function, I want to reference our canvas context and say that our fill style should be equal to no other than a string of red. And that's going to make our player red. Great. So now if we go back to our to-dos, we created a player, but now we need to actually get this player falling down towards the ground and then stopping at the bottom. So how do we go ahead and do that? Well, we're going to need to add some velocity onto our player class. What is velocity? Well, it's basically the measurement that's going to move our player around and be added onto our player's position. So if we want to go ahead and add some sort of velocity to our player, we want to make sure that we add that property within our constructor. So I'm going to add a this.velocity property. And velocity, since we're in a 2D space, can have an x velocity, which I'm going to set to 0 to start, and a y velocity, which I'm actually going to set to 1 to start. And by default, this y velocity is going to be pushing our player down because as you add positive numbers onto a position in canvas, your player goes downwards. Within the canvas's y-axis, 0 is on the top, and as you go further down, the numbers get bigger. So we have our velocity, but how do we actually get our player moving downwards with this velocity? Well, we don't actually have anything that updates our player over time. Right now, we're just calling all of this code at one time. It's not looping or anything like that, so we can't actually move our player at the moment. But we know we're going to need some sort of update function, which actually changes our player's properties over time. So what I'm going to do is within our player class, I'm going to add a new method called update. And here is where I'm going to alter our player's properties as we call this update function. So the first thing I want to do as I call update is call this dot draw. We're just going to call this method right here. Make sure we separate what our player actually looks like with what we're actually updating over time. And then I want to say that this dot position dot y, our player's y position, should have our player's velocity, specifically our y velocity, added onto it over time. So if I save this and refresh, we're still going to be in the exact same place. And you'll see if I go ahead and change our velocity to 20 and refresh, we're still in the exact same place. And that is because this would only really work if we moved this line of code right here above this dot draw. So if I were to change our position y before we actually drew our player right here, save and refresh, still in the exact same spot, but that's not a problem simply because we're still calling our original draw function. We're not calling update. So let me go ahead and illustrate this really quickly for you guys. If I were to go ahead and switch player.update, refresh, still in the same spot because I moved this back down beneath draw, but if I were to put it right above draw, you'll see that our player moves downward, but it's not moving downwards over time because we have no animation loop. So we might be adding velocity y onto position y, which is what we need to actually get our player moving, but we don't actually have the function in place which calls a loop, which is going to do that over and over and over again. So we need to create some sort of animation loop to get our player moving. How do we do that? Well, we can create a function at the very bottom of index.js called animate. And here we're going to call another function called request animation frame. And here we need to insert an argument of the function that we want looping. So what is the function that we want to loop? Simply the animate function that we just created. So we're basically using this recursive loop to call animate over and over and over again so we can begin changing our player's properties over time. And we can test that this is working by console logging out some text. And then we want to make sure that we actually call this animate function. And now if we refresh, go to our console, you'll see that this is being logged over and over again. We have a working animation loop in place. So now instead of console logging go, what we can do is we can replace that with player.update. So we're moving player.update within our animate function. We refresh and you'll see that it's drawn really quickly. Why is it being drawn so quickly? Simply because our velocity is very high. I turned it up to 20 earlier. Let's go ahead and change it back to 1. Save and refresh, and that's going to start moving downwards. And I just want to make sure that I'm drawing this out before moving its position. So I'm going to call draw first. Make sure that things are accurate when we start. And you'll see that's obviously being drawn and it's being pushed downwards. But it's creating this long banner-like line rather than allowing us to see the actual square's shape. So what we want to do is within our animation loop, we want to go ahead and get our context and then call clear rect. This is a function which is going to clear our canvas, take everything off of it, but allow us to call our player's draw function right after it. It's going to allow us to maintain our player's shape. So we have 4 arguments for clear rect. The first is going to be in X position. I want to clear the whole canvas from the very top to the very bottom. So what I'm going to do is I'm going to reference an X position of 0, a Y position of 0. That's going to put us up here. And then I want to say clear the whole width of the canvas. This third argument is the width. And then the fourth argument is going to be our height. So I want to clear the full height of the canvas as well. So if I go ahead and save and refresh, now we have our square in place and it is moving downwards because we have some sort of velocity associated with it. So now this is some very basic gravity. I don't even know if I would call it gravity. It's more just pushing our player down using velocity. But in order to get some sort of realistic physics in place, we want to go ahead and add gravity onto this rather than just pushing our player down with a simple velocity. So what is gravity? It's simply acceleration to our velocity's y-axis. So if I want some sort of global gravity, above our player class, I create a const called gravity. And I'm going to set this equal to, let's just say 0.5 to start. That should be a good intermediate value. And then within our update function right here, I want to make sure that I'm adding gravity onto our velocity's y-axis every time we call update. So what I can do here is say our velocity.y going to be plus equal to gravity, and that means we're going to be accelerating over time. So let's watch what happens when we do this. We can save, we can refresh. You can see that definitely has a little bit of acceleration associated with it. It looks a lot more natural. We can increase this value to make it go a bit quicker. See, that drops a bit quicker. We can go ridiculous like 4.5. Drops very fast, so you can fine-tune this gravity as you would like. But now we have the issue where our player just drops beneath our actual canvas. It doesn't stay in place. So let's start off by setting our velocity equal to 0. Even when we do this, we're still going to have gravity being added onto our velocity's y-axis. So you're going to see it's still going to fall downwards, but that's what we're going to need to start. And now we want to say to only add gravity onto our velocity's y-axis if a certain condition exists. So what is that condition? Well, we know that our player is just a square to start, so we want to reference our player's position, specifically the Y position, so on the very top, and then we want to go ahead and add on our player's height. So we're monitoring the bottom of our player right now. Now we know velocity is being added onto our player over time, so we need to make sure that we're adding on the velocity on the y-axis. And we want to say if the bottom of our player plus its velocity is less than the bottom of our canvas right here, then we want to keep adding gravity onto it. But the second that our player passes the bottom of the screen, we want to set its velocity equal to 0. So what do we need in this conditional right here? We want to say if the bottom of our player plus its y velocity is less than our canvas height, we're going to call this code right here that adds gravity onto our y velocity. But as soon as our player crosses this line, we're going to call an else statement that says this dot velocity on the y-axis should be equal to 0. So now if I save and refresh, you'll see that our player goes downwards because this conditional is true, but eventually, as soon as this becomes false, we're setting our player's y velocity to 0, which stops it altogether, and it gives us that gravity effect that we were looking for. So now we can go back to our to-dos, and we can check off number 3, gravity. So next up, we're going to be adding player movement. How do we do that? Well, we're going to want to focus on adding a few event listeners. So we're going to listen for events, specifically coming from our keyboard. So how do we add an event listener? How do we listen for these keyboard events? Well, at the very bottom, this is where I like adding my event listeners because sometimes I need variables that come before them, and it just really sections them off from things in a place that I like. So at the very bottom of our code, I'm going to call window.add event listener. This is a method, but remember, any method that comes from the window object, we don't actually need to call window dot. We can just go ahead and get rid of this completely, clean up our code a bit, and then we want to specify as a string what event is being called. So what event do we want to listen for? We're going to listen for the key down event, and this is a specific keyword provided by the browser. There are only a few of these that actually exist. You might have to look some up on Google, but off the top of my head, I know that this is a valid event called key down. And as I key down, press a key on my keyboard, I want to call some sort of function in return. So I'm going to call an arrow function, which is just simply opening and closing parentheses, equals sign caret, opening and closing curly bracket, and here I can console log out some code to make sure this is working. So I'm going to say key down whenever I press a key on my keyboard. So if I go ahead and save and refresh and I key down anywhere, you'll see no matter which key I press, we are calling this key down code. So now I want to say whenever we press D on the keyboard, we go to the right. Whenever we press A on the keyboard, we go to the left. Whenever we press up on the keyboard, we go up. We're not really going to be going down, so it doesn't really matter for S, but it's pretty typical to be using WASD to move your character around within these kind of web games. So how do I actually say I only want to perform a specific action when a certain key is pressed? Well, we're going to need to monitor which keys we're actually pressing. So within this arrow function, this callback function right here, an event object is automatically passed through it from add event listener. So if I go ahead and console log out this event object, you'll see exactly what this consists of as I begin to press on the keyboard. So you'll see we have a keyboard event, and inside of here we have a bunch of different properties associated with the event that just happened. Now I want to look for the key code. The key code is going to determine which key we actually pressed on the keyboard. So you'll see right here, if I were to press A, well, make sure you select your canvas first and then press A, I get a new keyboard event. I can open this up, and I have a key code of 65. If I were to press a different key, we would get a different key code. Now it's kind of annoying to have to open up this keyboard event over and over again to see what key code we're pressing. So here's a nice shortcut for you using JavaScript destructuring. So here, since we are referencing an event object, we know we want to get a very specific property from it, specifically key code. So if we just want to grab one specific property that we know is there, we can replace our event object with an opening and closing curly bracket and then specify that property that we want, which in our case is going to be key code with a capital C. So really, we're just grabbing this property right here directly, and we don't have to console log out all these other properties that come with that original event object. So now I can just console log out key code. We refresh over here, and now when I begin pressing A, we see we have a key code of 65. S, we have a key code of 83. D, 68, and then W is 87. So these are the key codes we want, and we're going to want to go ahead and say whenever we press one of these keys, we're going to call a different action. So what I'm going to do here is I'm going to use what's called a switch case statement. And to write one of these, we want to go ahead and write switch and then opening and closing parentheses. And we're going to switch out our key code. And then we're going to add an opening and closing curly bracket. Now we're going to determine a case and say, which key code do we want to swap out here? Well, we know that our A is going to be 65. So if I write 65 here and then add a colon, I can begin writing code that is only called whenever we press our A key, which has a code of 65. So I can console log out. This is left. And then I know I am done with this case statement, so I can add a break statement here. But you'll see if I go ahead and delete this original console log, save and refresh, and then I hit A, we're going to console log out left, but once I hit S, D, or W, we are not console logging out that code. So that is how you're going to determine which keys are being pressed, is using this key code right here with a simple switch case statement. So we want to go ahead and make sure that we also add cases for S, D, and W. So I'm going to actually console log out those key codes one more time so I can see exactly what those key codes are. So now I want to do this for S. Key code is 83. So I'm going to go ahead and copy this right here, paste it in. We know that this is going to be a case of 83. This isn't going to be left, but rather down. I know I'm going to want two more, so I'm just going to go ahead and paste these in two more times. This one is going to be right, and then the last one is going to be up. But we need the specific key codes. So if I go back here, click on our canvas, hit D, that's going to be 68. Hit up, that's going to be 87. So now I can replace right with 68, and I can replace up with 87. So now, if I comment this out right here, save and refresh, if I hit A, we're going left. If I hit S, we're going down. If I hit D, we're going to the right. And if I hit W, we're going up. So we're now monitoring all the events that we need to get our player moving. But how do we actually move our player now? So I think the easiest key to start on to move our player is actually going to be our W key, which sends our player up. So if we want to go ahead and select our player, and make sure that he's going upwards, well, what do we need to reference? We need to reference our player's velocity because that is what's going to actually be pushing our player around. We know we want to push our player upwards, so we want to reference the Y velocity. Now, all we have to do is say we want to add on a specific value on our player's Y velocity, and that should send it upwards. We might actually need to subtract this because it might push it downwards, because remember, the larger the value on the Y axis, the further down you go. So if I save and refresh and then hit W with that code, you'll see our player is going down, which is not what we want. We want to make sure that we're actually subtracting this. So we'll go ahead and say instead of plus equals, we're going to do minus equals to subtract the current value of our velocity Y with 20. Refresh, hit W, and you'll see our player just immediately goes upwards. Why does this work? Well, we're simply subtracting 20 from our player's Y velocity, which we'll go ahead and send it upwards. And remember, we're constantly adding our Y velocity onto our player's position. But since we added gravity, it's always going to pull our Y velocity down until it hits the bottom of the screen, which is where we set its Y velocity equal to 0. So that's why this works immediately right off the bat. It's simply because we have all this gravity code in place to make sure that our player is pulled back downwards whenever we add, or more so subtract, a value from our player's Y velocity. So very nice on the Y-axis, but now how do we get our player moving on the X-axis? You'll see if I try the exact same thing by copying this line of code, let's go ahead and focus on right here. If I go ahead and swap this out with X, and we want to go ahead and add 20 on our player's X velocity, if I save and refresh, and I hit D, nothing's happening just yet, and we need to go ahead and go focus on our player class. And within our update function, we need to make sure that we're adding on to our player's X position, our player's X velocity. Otherwise, our player is never going to be moving on the X axis. So we need to make sure we add that on first. So if I save and refresh and then hit D, you'll see that our player now has 20 added onto its X velocity, and it just zooms off the screen even though I only pressed it once. Let's go ahead and change this to something else. Let's go ahead and say we're adding on just 1 to our player's X velocity. If I go ahead and refresh, hit D, we're now moving by 1, but you see, hands off the keyboard, we're still moving, should not be moving any further. So how do we make sure that we stop moving when a player lifts up on a certain key? Well, we're going to want to add in an additional event listener, not for key down, but for key up, and then we're going to set our player's velocity equal to 0. So here what I'm going to do is I'm simply going to copy all of this code where we created this new event listener. I'm going to paste it in again. And then I want to focus on the events for not key down, but rather key up. And all the key codes are the exact same for key down and key up, so we don't really need to worry about changing any of these. But here, I want to say whenever we key up on the right key, so D, we're going to set our player's x velocity equal to 0. So now if I save and refresh, and I hit D, we go to the right, but it stops immediately as soon as I pick up. But you'll see if I hold it, we're actually getting a little bit of acceleration. That's because we're constantly adding on our player's x velocity. We could even set this equal to 1 and refresh, and then hit D, and you'll see that this is no longer having velocity added onto it. But this is not really the way that I would control our player's movement on the x-axis, because right now my D key is just being pressed over and over and over again because I have a setting on my Mac that tells it to do so whenever I press down. But if you have a computer set up so that each time you press and hold, it only presses once, you're only going to move by 1 pixel because that's always specified right here whenever we key down. So we're going to want to make sure that our player is moving in a way that's a little bit different than just using event listeners for the x-axis. So we're not actually going to be setting our player's velocity right here within key down. We can also get rid of player's velocity on the x-axis for our right key. Here on key up, we're actually going to be doing things a little different. So here, right where we created our player, I'm going to create a new constant. This is going to be equal to keys. And then I'm going to set this equal to an object, and now here I'm going to define the keys that I want to monitor. So I know I want to monitor our right key, and this is going to have a property of pressed, which tracks whether or not our right key is pressed. So by default, it's not going to be pressed. I'm going to set it to false, and now I want to make sure that I monitor our left key also, so I'm simply going to copy our right property and change right with left. Save and refresh. And now we can also monitor whether or not our left key is pressed as well. So by default, both of these are going to be false, but we know whenever we key down for something such as our right key right here, we want to go ahead and select that key's object. We know we're selecting our right key right here when we press it down. We want to make sure that we set its pressed property equal to true. We want to do the same thing for left. So I'm going to copy this line of code right here, paste it into our left key, which is 65, and make sure that I'm changing out right with left, so that whenever we press down on the left key right here, the A key, we are setting this key's left pressed property equal to true. And now we want to make sure that we're setting this equal to false whenever we are keying up, which means it's no longer pressed. So keys left pressed is equal to false whenever we hit the left key, and then whenever we do right, which is the D key, keys.right press is equal to false. So now, if I go inside of our add event listener key down right here, and I console log out keys.right.pressed, and then I do the exact same thing within our key up. Whenever we press down on the right key, this should be equal to true. And then whenever we let up, this should be equal to false. So let's go ahead and refresh. If I hit D, you'll see that this is equal to true. And once I lift up, it's now equal to false. So that is working exactly as we would like it. I'm just going to go ahead and delete these for now. But now we can use these keys properties within our animate loop to make sure that our player is moving either left or right. So here's what I'm going to do. Right beneath player.update, I'm going to say if keys.right is pressed down, then what am I going to call? I'm going to go ahead and call our player, select its velocity on the x-axis, and I'm going to set our velocity equal to 5. So now if I refresh and I hit D, you'll see as long as I hold down our right key, we're moving to the right. But if I refresh that, holding down, and I let go, well, actually, we're still going to the right. That's an issue. In order to stop our player, we want to add an else statement, which is going to be called, obviously, if this is not true. So if our key is not pressed, meaning it's up, what do we want to happen? Well, we want to call our player's velocity, get its x, and set it equal to 0. If you only have one line, like I have right here, you don't need to add the brackets. Just a cool little JavaScript tip. save and refresh. So now if I hold down D, we're going to the right, but as soon as I lift up, we stop, because now we have our movement code running within our animate loop. Let's go ahead and do the same thing for our left key. So if I add in an else if statement right here before else, let's say our keys dot left whenever this is pressed, add in a curly bracket because we're probably adding some additional code here. Whenever we're pressing the left key, we're going to set our player's velocity x equal to not 5, but rather -5. We're just going to send it in the leftwards direction. But if that key is not pressed and the right key is not pressed, well, we're going to set this velocity equal to 0. Pretty cool if else statement right here to get things working as we move our player. So if I go ahead, hit right, we're moving to the right, lift up, we stop. And if I hit A to go to the left, we go to the left. And then we stop as soon as we lift up. We can go off the screen, we can come back, we can jump while we're doing this. We're jumping really high right now. Might want to turn down that velocity a little bit on the y-axis, but nevertheless, this is looking really good for having player movement in place. This is really all we need to get started. So if we go back to our to-dos, we can go ahead and knock off player movement, but now we need to actually create the platforms in our game, which are going to be scrolling and moving so our player can jump on them, avoid pits of death, and so forth. So in order to create platforms, well, we're going to need to create some sort of platform class. So right beneath our player class, I'm going to add one more called no other than platform with a capital P. And this is going to have opening and closing curly brackets with a constructor method inside of it. So a platform, let's go ahead and think. What kind of properties does a platform have? Well, we know a platform is long. It's probably a little thinner on the height section, has an X and a Y coordinate so we can place them in multiple places on the screen. So let's go ahead and add a position for our platforms. And a position is going to have an X, start off with 0. It's going to have a Y, start off with 0. We know we're going to have a width, set this equal to, let's just say 200 to start. We're going to have a height, this is going to be thin, call this 20. And then we want to be able to draw out our platform. So I'm going to add the arbitrarily named draw function. And then we're going to call our context and call fill_rect. So fill_rect, all it does is draw a rectangle like we did with our player. It takes an X coordinate, which we're going to reference our player's X position. A Y coordinate, where we're going to reference our player's Y position. It takes a width, so this dot width. And it takes a height, so our player's height. That should be all we need to get started with a platform. I'm actually going to say our c.fillStyle for our platform should be equal to blue to make sure that it's separated from our red player over here. And now I can create a new platform. So I'm only going to create one to start to really make sure that this is as clear as possible for how things work. I'm going to create a constant called, not player, but platform. This is going to be equal to a new platform. So now that I have the platform implementation, I can call not platform.update, but rather platform.draw. These aren't going to be moving at the moment. We'll add an update function soon, but for now we can just call draw. We might not even need the update function at all, actually. But if I go ahead and add platform.draw right here and refresh, you can see our platform is being drawn in the very top left-hand corner of the screen. Why is it being drawn up there? Well, it's because our position is 0, 0. So we want to go ahead and set this somewhere over here. So I'll say our X should be equal to 200. Our Y should push it down to something like 100. Save and refresh. And that seems to be in a good position. So right now, if I try jumping on this, you'll see our player just falls through it. You can hit up multiple times to go higher. We're just falling right through it every time. That's not how a platform works. We need to code this platform so that when our player jumps above it and falls back down, that the player stops on top of it. And then when it moves to the side, we want to make sure that our player falls off the side. So how do we actually do that? Well, we're going to need to use rectangular collision detection. If you're new to rectangular collision detection, I just did a video on it. You can check it out right here. I think it's on this side. Just go ahead and check that out real quick. It's a short video that'll teach you how to detect collision between two rectangular objects. But nevertheless, let's go ahead and code that in, and I'll teach you how to do it along the way. So we're going to want to detect this collision within our animate loop, because that is where our properties are going to be changing over time. So all I want to do is add in an if statement that tracks whether or not our player's Y position plus its height, so the bottom of the player, whether or not the bottom of the player is less than the top of our platform. So what I can say is if our player's position on the y-axis plus the player's height, so that way we get the bottom of our player, is less than or equal to the y position of our platform. So platform.position.y. What do we want to do to our player? Well, we want to select our player's velocity on the y-axis and set it equal to 0, and that's just going to make our player stop moving altogether. So with just this, let's go ahead and see what happens. Save and refresh. If I jump above it, we're going to jump up, and eventually our player stops, but it stops going upwards, and it doesn't actually fall back down or touch the platform. So we need to make sure that this is only actually being called when our player is going downwards, and we want to use the same sort of code that we use to stop our player with gravity when the player hits the floor. So I'm going to add in an AND statement that grabs our player's position on the y-axis plus the player's height. We're going to also add on our player's velocity on the y-axis, and we want to say if all of these are greater than or equal to our platform.position.y, then that is when we want to set our player's velocity equal to 0. So save and refresh. If I jump above it, we're allowed to go upwards, but as soon as we actually hit the platform, our player stops. So that is how you code collision detection on the y-axis for rectangular collision detection that tracks the bottom of one and the top of the other. But you're going to notice, as I move to the right, our player is not falling down, and as I move to the left, our player is not falling down either. That's because this conditional is still being called, because it's only tracking our player and the platform on the y-axis. It's not actually tracking anything on the x-axis to say that once we're off of the platform, our player needs to fall down. So how do we make sure our player falls down whenever it is off of the actual platform? Well, we're going to add in another conditional here that tracks our player's position on the x-axis. So we want to track the right side of our player. To get the right side of our player, we want to add on our player's width, and this is going to give us the value for the right side of our player. So we want to say if the right side of our player is greater than or equal to our platform's left side over here, so our platform.position.x, then that is when we want to set our player's velocity y equal to 0. Not when it is over here, not when it is less than this point on our platform. So if I save and refresh, see if I try jumping on the left-hand side, not getting any platform stuff, which is great, that's what we want. But now when I'm on top of the platform, our player actually lands, and if I go to the left, we fall back down. And this is pretty tight code. You'll see as I move to the left, our player is still standing, but as soon as it goes off just a little bit, just a pixel, it falls back down. We need to make sure that we add code to make sure that our player falls when it goes off the right side of the platform. So here's what we're going to do. We're going to add one more conditional that tracks the left side of our player. So we're going to grab our player position dot x, and we want to say we should only be setting our y velocity equal to 0 if this value right here on our player is less than or equal to our platform position dot x plus the platform width, so the right side of our platform. I'm going to add on our platform dot width, and I'm just going to comment right here, this is platform collision detection, so I know exactly what this conditional does without having to look at all this code. So now if I save and refresh, you'll see collision detection works over there on top of the platform, and now if I go off the right, we fall back down. So that is how we're going to code our player to be able to jump on top of platforms. So if we go back to our to-do list, we can go ahead and check off platforms, but now we need to actually scroll the background so that when our player moves to the right, the platform is actually moving to the left, creating the effect of a Mario game and a side-scroller. So you see right now, our player is able to go anywhere on the screen, but that doesn't really make sense for a side-scroller because as we move to a specific point, the background needs to move to create the illusion as if our player is moving. So once we get to this point right here, right about here, we want to stop our player from moving altogether. And once we hit this point, that is where we're actually going to be moving all of our platforms. So how do we actually do that? Well, if we go ahead to our animate loop where we are moving our player, we're going to want to add in an additional conditional. So whenever we press the right key, we are currently moving our player to the right. Well, we want to make sure that our player can't move past this one specific point right here, and that is where we're going to start moving the platform. So how do we limit where our player is actually moving? Well, we can add a conditional right here to this if statement that says if our player's position on the x-axis is less than 400, then we want to be able to move our player to the right. Otherwise, we're going to hit this else conditional, which stops our player from moving altogether. So if we save and refresh, we start moving to the right, and once we hit 400, we stop moving. Now we want to do the same thing for the left side of the screen, otherwise our player can go off the screen. We might want to stop it at around 100, just so that when we start moving to the left, we can see a little bit of what is going to be coming our way from behind. So if we want to do this, we want to focus on our else if statement right below. And here we can add a conditional that says if our player's position on the x-axis is greater than 100, then we want to push our player to the right. Otherwise, we're going to hit this else statement, which sets our player's velocity equal to 0. So we save and refresh. We go to the right, we stop, we go to the left. Once we hit 100, we stop as well. So now whenever we hit these edges is when we can actually be moving our platforms. How do we move our platforms? Well, we're going to want to focus in on this else statement. I'm going to go ahead and add some brackets here because this is no longer going to be one line of code. It's going to be multiple. And I want to say whenever we hit one of these edges, so whenever we're inside of this else statement, I want to also monitor for when our keys, the right one specifically, is pressed. So whenever we hit one of these edges and our right key is being pressed, what do we want to do? We want to select our one platform, and we want to get its position, .x, and we want to what? We want to be moving our platform to the left whenever our character is going to the right. So in this case, we want to subtract equal. How much? We want to subtract equal 5 because that is currently the rate at which our player is moving, so it's going to make sure that the platform is moving at the same rate. Make it look like everything is moving exactly as it should be. So if I save and refresh that, when we hit the right side of this limit right here, we should activate this else code, and if we're still holding down on the right key, we're going to be moving our platform to the left. So if I refresh, we hit, and eventually our platform goes to the left. But we want to do the same thing for when we hit this left restriction. We want to be moving our platform over to the right. So what I'm going to do is I'm going to add an else if onto the end of this current if conditional and say if our keys left is pressed, then what do we want to do? We want to go ahead, select our platform, get its position on the x-axis, but rather than move it to the left, we're going to move it to the right by 5 pixels for every frame we're holding down our left key. So now if I save and refresh, if I go to the right, platform moves to the left. If I go to the left, platform moves to the right. So we're creating the illusion of movement. And the cool thing is, all this still works with our collision detection code, no matter where this platform moves. So a really cool effect for all the code we already did, a nice enhancement to get things working with movement. So now let's go ahead and add multiple platforms because we're going to want to jump around a bit on our level, make things a little harder than just being able to jump on one platform. How do we add multiple platforms? Well, we're going to want to focus on where we're creating that one platform constant. And rather than create a constant for one platform, I want multiple platforms. Let's go ahead and make this plural. I'm going to set this equal to an empty array, and I'm going to take this new platform that we are currently creating and place it inside of this array that we just created. So now that we created this platforms array, I can go ahead and get rid of our previous platform constant, and now I just need to make sure that every place in which we had that platform constant, I need to replace it with some version of platforms instead. So you'll see right here where we are updating our player, we are also drawing out that one platform, but platform is no longer available to us. We have platforms now instead. And we have one platform inside of this array. So how do we access this one platform? Well, what we're going to do is select our platforms constant, and we're going to loop through this array with for each, uppercase E. This is going to be a method. And then what kind of object do we want to select from this platforms array? Well, we want to select the one individual platform. So we're going to call this variable right here, platform. This is arbitrarily named, by the way. This is a name that I came up with because it makes sense. We want to select the platform within our platforms array. And this is going to be a small arrow function in which we can determine what to do with every platform that we are currently looping through. What do we want to do? We simply want to draw out that one platform we're currently looping over. So I can just go ahead and simply copy paste this platform.draw code inside of platforms.forEach. And this code right here will function exactly as expected. But if I were to save and refresh, we're going to get errors because there are other locations in which platform is not defined. Let's go ahead and find those locations. It's going to be right here within our if and else if conditionals, where we are currently changing the position of each platform. Well, not each platform, but just that one previous platform. So what I can do is I can copy and paste this for each code right inside of these conditionals in both locations. Save to reformat that, and then I can take this code that we already created, replace platform.draw with that code that shifts our platforms, save and refresh, and it seems that there is another location which platform is being used. It's going to be right here within our collision detection conditional. So all I need to do here is make sure that I copy our platforms for each code, paste it right above our if statement, and then make sure I close this out with a closing curly bracket and a closing ending parentheses. And as long as this conditional code is inside of this for each, well, we have a platform in which we can reference within the conditional, save and refresh. Now no more errors. But what happens is we still have this platform in place. All of our code still works as expected, but this is inside of an array, which gives us the ability to create multiple platforms. So if we go back to our array, we can create another platform by copying and pasting new platform, adding a comma to the end, and pasting in another new platform. If I save and refresh, well, we do have two platforms, but they're going to be drawn on top of each other. So we want to make sure these platforms are in different locations, and that is where our platforms constructor method is going to come in handy. So rather than just use a static value like we have right here for position, we want to be able to pass values into each individual platform to put them in different locations. So instead of just referencing an x and a y like this within our constructor, I'm actually going to pass through a singular object. And then I want to specify what kind of properties do I want to pass through into this. Well, I want an x that is going to represent our position, and I want a y that is going to be our y position. So now, instead of referencing a static value of 200, I can reference the x that we're going to pass through, and I can also reference the y that we're going to pass through. Now, quick JavaScript shortcut for you is x:x is the exact same thing as just putting x here. If this property name is the exact same name as the value you're assigning to it, well, you don't need the colon and the value. This is the exact same thing as this right here. So we're going to clean up our code a bit by saying x and y should be the properties for position. And now that we have these x and y properties being passed through, we can go ahead and pass them through each individual platform. So rather than just specify two values with x and y, like 200, 100, that is not clear to me what those values represent, which is why I passed them through as an object instead. With an object, I can specify that our x should be 200 and our y should be 100. It's a lot more clear right here that those are positions than just passing through 200, 100, which is why I use that object. So now that we have an object there for our first platform, we can add an object for our second platform with an x of something different, so something like 500, and a y of 200 to make sure that it's placed in a different location somewhere over here. So if I save and refresh, now we have two platforms, and since we added all that for each code below within our animation loop, everything still works exactly as expected, everything is moving, and all of our collision detection should work as well. We can jump between two different platforms, and we can create as many platforms as we want to continue this game. So if we go back to our to-do list, we scrolled the background. So next up, we're going to focus on a win scenario before we actually begin swapping out these platforms with images to make our game look like an actual game. So how do we create some sort of win scenario? To make this as quick as possible, our win scenario is just going to be once we reach a specific point, we're going to console log out. This is how you win the game. Typically, you would create some sort of HTML pop-up that says, congrats, you win, or you'd have Mario slide down a flag or something like that. But it's a little more complex and time-consuming for the remainder of this tutorial, at least to keep things within a certain time limit. So that'll actually probably be more of the premium course, but I still want to give you guys the idea of how to create this win scenario in the first place. So what we're going to do is say once our player reaches a certain position, once we traveled, I don't know, maybe 1,000 or 2,000 pixels to the right, that is where we're going to win the game. And in order to track how far our player has moved, we're going to need to create some sort of let, because we're going to be changing this over time, called scroll offset. So this is going to be how far have our platforms actually scrolled on the screen. This is going to be equal to 0 to start, because platforms don't scroll before we start the game, but we're going to want to be tracking this value right here. When do platforms scroll? Well, they're going to be scrolling within these two conditionals. They're going to scroll to the left whenever a right key is pressed, and we reach this limit right here. So we're going to be adding on to our scroll offset a value of 5, and then whenever our left key is pressed, we're going to be subtracting a value of 5. So we can track what this value is equal to when we console.log scroll offset below, give it a save and refresh. Now you'll see it's currently at 0, nothing's happening, but as we begin to move to the right, still 0, because this is only going to be changing when our platforms actually move. You'll see now they're moving, and this value is changing. When I stop, eventually it's going to stop as well. And I can keep going to increase this value. If I go back to the left, our scroll offset decreases, and eventually reach the point where we're on the negative side. These are a little further out than they were originally. So now that we have this scroll offset value at the very bottom of our animate loop, we can add a conditional that says if our scroll offset is, I don't know, let's say greater than 2,000, and this can be set to whatever you would like, we're going to console log, you win. So if we save and refresh, we go to the right, everything's dandy, and eventually once we hit a scroll offset of 2,000, we should see the value, you win, and eventually it's going to be this point. We traveled far enough to the point where we know we won the game. Congrats, we made it past all the crazy things happening which we haven't created yet. So we can go back to our to-do list and say we created some sort of win scenario for our game. We know how we're going to win the game, but it's still not much of a game because we haven't created any challenge such as fall pits, which we'll get to. But I think right now it's time to make sure that these platforms are replaced with actual images. How do we get images into our game? Well, we're going to need some sort of image file to start, and I have actually created a few images for this game specifically. These are all created directly by me, so if you would like to use them in your own game for personal, commercial purposes, I don't really care what you use them for, so go ahead and feel free to use them for whatever. I'll also supply a link to these directly within the description of this video. So you'll see this is one of the first images I created, just a simple platform which is going to be acting as the base for our player, so you can begin creating fall pits. And these are actually going to replace these to start. They're not going to look great, but eventually once we start piecing everything together, they will. So what I want to do is I want to go ahead and select this one platform image that I have, and I want to open up another window here in which our project was created. So I'm going to go back to web and then look for Mario game, should be right here. And then inside of here, I'm going to right click, hit new folder, and call this IMG for images. So now that I have this folder, I'm simply going to drag our platform inside of it. And now when I open up Sublime Text, you'll see we have this image folder in place with a platform. So now I should be able to import this into the game. How do you typically import images into a JavaScript file? Typically you would do this, import, let's say platform, from where do we want to go? We want to go inside of the image directory, like so, and then we want to reference platform.png. And now I want to console log this out to make sure I'm selecting it. So console.log platform, save and refresh. Well, we get an issue with cannot use import statement outside of a module. So to fix this, we go to index.html, declare a type on our script tag, and set this equal to module. So if I save that and then refresh, well, now we get another error. This is going to be a CORS related error. So since we are referencing a file directly from our file system, we can't really reference or import images like we want to within our game. The browser just does not allow it. So what we have to do is we have to switch over to some sort of server which allows us to serve our images as imported modules. It's a little annoying, but this is going to be the way you want to do things when importing images into your game. So what are the next steps? Well, In order to create some sort of server, while you can use VS Code, there's a live server extension which does pretty much all this automatically for you, spins up a server, allows you to visit this at something like localhost 3000. But I don't have VS Code, I'm using Sublime Text, so we're going to do things a little differently. What I'm going to do is I'm going to visit a repo I made called the Canvas boilerplate, which is going to allow us to create a new server. I'm just going to go ahead and open up a new tab, type in GitHub, and then I'm going to type in Canvas boilerplate. And the very first result should be Christopher for list Canvas boilerplate. That is my repo. We're going to go ahead and click that. And now we're within the repo. I'm also going to leave a link in the description for this. What do we have to do here in order to download this? Well, all we have to do is clone the repo. So I'm going to copy this line of code right here. Go to our terminal. You're going to need to make sure that you have Git installed. There are plenty of tutorials out there that'll show you how to do this. And then I'm going to go into that web directory that I created. So if you're new to terminal, this is an easy way to do it. We can just type in cd for change directory. And then I'm going to open up our Finder again, find the location of our project directly. So right here within my web folder, it's going to be Mario game. So I can just drag Mario game into our terminal. And once I hit cd, it's going to put us directly within this folder right here. So now we're inside of our Mario game folder. This might not actually be where we want to clone our game though, because we're going to be making a completely separate instance of what we just did. So actually, it makes more sense for us to be inside of the web folder rather than the Mario game folder. So if I want to go back one folder, so we're in Mario game right now, but if I want to go inside of this whole thing, I can type ... to go back. Now we are inside of the web folder right here. So this is where I want to paste this code that I got from Canvas boilerplate. I'm just going to paste it in, hit enter, it's going to clone it, and it pasted it in as Canvas boilerplate. So now if I look in within Finder, we have a project called Canvas boilerplate. But we don't want to call that, we want to call it something else. So Mario-game-server makes a little more sense than what we just had. So now when we go down, this is our new project. What do we need to do next? We need to install our project dependencies. What are those? Well, those are just packages that are going to help us along the way with development, such as spinning up a server and adding a few bonus effects, which we'll see shortly. So I'm going to make sure I have Mario Game Server opened up within Sublime Text. And then I want to make sure that I also cd into Mario-game-server to run this additional code to install dependencies. So you can install it with the package manager yarn or npm. npm is more readily available to most people on their computers, so I'm going to go ahead and use that. If you don't have npm available to you and this does not work, you need to make sure that you install node from nodejs.org, I believe it is. Just go ahead and type in install node.js and it should give you instructions on how to install node. npm comes with it, so as soon as you install node, you should be able to run this command as well. So this is just installing all the packages associated with the boilerplate. And now we can actually run Webpack, which is going to spin up that server for us. So now if I go ahead and run npm start within our terminal, it's going to automatically open up this URL right here. This is going to be our server URL. And it's going to give us this blank boilerplate with Canvas in which we can work on. Now we already coded a bunch of stuff for our game, so we want to make sure that we switch it over to our new Mario Game Server project. So I'm going to go ahead and make sure that I have our original project open up over here, where we're importing everything and we created all this code. I'm going to select it all with Command A, copy it with Command C, go back over to Mario Game Server, go inside of the JS directory, and then within Canvas.js, I'm just going to Command A, hit delete, get rid of everything, and then save with all the new code that we already created. We also have a different index.html file, so we need to make sure we copy over our code from here. All we really need to copy over here is going to be setting our body to have a margin of 0. And actually, it doesn't, we don't actually need to do this because it looks like within the boilerplate I already did it, which is great, so we can actually skip that step. Sorry about that. So now, when we save and refresh, well, we have some sort of error here because our game isn't loading. What is the error? Well, it's a different error associated with our platform image. So we're on the right track here. This error is a lot better than the other ones we just associated with. The only error is we cannot find the actual image we want to reference. How do we go ahead and make sure that image is there? Well, we just need to simply make sure we drag it into our Mario Game Server project. So back within Finder, we're going to go over to our original Mario game, get this image directory. I'm going to copy the whole image directory with Command C, go back to Mario Game Server, and then within our source directory, I'm going to Command V to paste in that image directory. So now, within canvas.js, we just need to make sure that we're referencing this platform image correctly. And we know we are currently within a JS folder right here. So I actually want to go back one folder into .source with a ... and then reference image/platform, which we are currently doing. So if I save, minimize this, refresh, our game works once again, everything functions correctly, but we have this localhost URL, and our image is being outputted by Webpack with this complex URL/name. The name doesn't really matter, but this is what we need in order to reference our image and get it into our game correctly. So now that this image is imported, how do we get it into our game? Well, we're going to want to draw out our platform using draw image instead of fill rect like we have right here. So we can go ahead and get rid of this current draw code. We're going to use c.drawImage instead. So this takes an image, an X location, and a Y location. So each platform is going to have some sort of image associated with it. It might be variable, so I'm going to pass it through as an argument right here. And then I'm going to set this .image equal to this image we're passing through. And now we can use this .image to draw out the actual image, the actual platform. So like I said, draw image takes a few more arguments. It's going to be this .position.x, and then the third one is going to be this .position.y. Where is it located on the screen? So now we're not going to see anything because we're currently trying to draw an image without this .image being set. We need to make sure that we're passing through some sort of HTML image into our platform object. So I'm going to go ahead and add a new property right here, and then we need to create an image, an HTML image, using JavaScript. So what I can do is create a new constant called image, set this equal to new image. This is a default object constructor provided to us from JavaScript. And that is going to create a new image object, but now I want to set this image's source equal to what? Well, the source of the image we imported at the very top of our file. We called this image source platform, like so. And now if we console log out image, we should get that image HTML outputted into our terminal. We actually have an error right here because image is not set. We can just go ahead and set this equal to an empty string to make sure our code is working. Save and refresh. And we're still getting errors, but our image is being outputted at the very top. This is our image HTML object, which we're going to use to actually draw our image. So now that we have image, we can go ahead and replace image right here with this image constant. So image is going to be equal to image, and whenever these two have the same name, we can get rid of the second value. Save and refresh. Now our platform is being put on the screen. We're still getting errors though, because this platform right here doesn't have an image associated with it. So I'm just going to go ahead and copy image, add a comma to the end of this, and then paste in image. So both of these platforms are going to have the same exact image as you see. So we can move around. These platforms move. And we can even jump on top of them, at least for a little bit, but you'll see eventually we fall off because we need to determine the exact width of these platforms to make sure our collision detection code is working correctly. So why isn't our collision detection code working correctly? Well, if we look at our platform, each platform has a width of 200 associated with it by default. The thing is, well, our image might not be 200 pixels wide. This is definitely longer than that, so we need to make sure that we're setting this width equal to the width of the image we're passing through. So what we can do is, I'm actually going to move this .image above our width. It doesn't really matter the location, but it kind of makes sense to load this image first before we start affecting things like width and height. And what I can do is, I can just say that this .width should be equal to our image width. And now on save and refresh, just by doing that, you'll see we land on the top of one of these platforms, and now we can move across the whole thing. Now the height of this doesn't really matter too much, but it does kind of make sense to set it equal to the height of the image as well. So I'm going to go ahead and set this equal to image.height. Save and refresh. Hopefully things still work. They do. So now we can walk across this whole platform. We can drop down on the next one. Cool thing is, we can move to the left, and we're not going to see our player even though he's on top of the platform. And this is a simple fix. If we go back to our animation code, over here, we are drawing our player before we draw any of the platforms. We always want to make sure our player is in front of the platforms. So our player.update is going to be the last thing we call, the last thing we draw on the screen. So just by doing that, If I jump on top of one of these, we're good. And now I can move in front of one of these other platforms. So looking great with our platforms being drawn on the screen. But these are more of floor platforms than things we actually jump on top of. So we want to put these below our character to create some sort of illusion of movement rather than being in random locations on the screen. Now right now our canvas is set to be the full width and height of our browser window. This might be a little annoying for someone who has a smaller screen than what's allowed here. It makes our game responsive, but our game is going to be a lot harder to set up with responsiveness compared to if we were just to make it a static screen size. So what I'm going to do is I'm actually going to change at the very top the size of our canvas to not be equal to inner width, but to be equal to something with a 16:9 aspect ratio. So 1024 and then 576. We're going to limit the location in which our player can actually play. So now our canvas is a specific width and height, but it's kind of hard to tell what part of our canvas is playable and what part is just HTML background. So within index.html, I'm going to go ahead and set our body to have a background dash color of black so I can see what's part of our game and what isn't. Save and refresh. Still not really helping us too much here, but now within canvas.js, if I go down to our animation loop where we are clearing our rect, we're not going to clear a rect anymore, we're actually going to fill a rect, but we're going to make sure that this rect has a fill style of white so that our canvas can be differentiated from our HTML background. So I want to save and refresh. You can see this is the playable area within our game. Everything else is not playable. Eventually this goes off the screen over here. So now we have a fixed dimension in which we can create our game without any issues regarding responsiveness. So it is kind of annoying that our canvas is in the top left-hand corner of the screen rather than being centered directly. So if you're a little new to CSS, this is how you're going to center the canvas really quickly. We're going to add a display of flex. We're going to add an align dash items of center, and then we're going to justify our content and set it equal to center. If you'd like to learn more about CSS, I have a complete masterclass on all of this, which will teach you in depth on how to use all these properties, but it's a little out of scope of this tutorial. So if I save and refresh, now everything is centered at least horizontally, right? But we want to make sure this is centered vertically. Align items should be taking care of that, but right now our body isn't the full height of our actual browser window, which is why this is not being centered vertically. So all I have to do here is make sure that I set the height of our body equal to 100 view height, the full view height of our browser window. And with that, now this is perfectly centered. We can play our game without any of annoyance of where our canvas is on the screen. So let's get these platforms moved beneath our player now that everything is set up correctly. Where we are creating our platforms, all I really need to do is eye this. And we can go ahead and set these to fixed values now that we made our canvas fixed. So let's go ahead and change this to something like 600 for the Y value. That moved it off the screen, so a little too much. Let's try 400. That's looking a little better. Let's try 450. And maybe a little more, even though that seems to be very close, so 470. And that is going to put us in a good location to have some sort of platform. But we also want to make sure this starts off at 0, so it's going to start off on the left-hand side of the screen. And we have a little bit of white space right here. We can just change this to -1. No more white space, but this is now acting as a platform in which our player can move on, rather than just fall down and hit the bottom of the screen, which is actually going to be acting as our player's death sentence. Oh no. So let's go ahead and make sure that this platform right here is also down below. Gives us something to move on. We know that our Y is going to be 470 for all these ground platforms. But even though this looks really good, these match up really well without us having to do anything, it's still overlapping on the left-hand side. So how do we make sure they're not overlapping? Well, we want to make sure that this is moved over to the right by the width of this platform image. So we can go ahead and select our image. Instead of reference 500 directly for X, we can reference our image's width, like so, and that's going to move it over almost perfectly. So this works for our game. We have a little gap here, and that's my fault because I didn't design this 100% correctly in Illustrator. But we can always take into account for this gap simply by minusing a small value from our image width. You'll see we even have a little gap right here. We might want to do 3 instead. And that fixes that gap, makes everything look quite perfect, and now we have this nice platform area in which our character can walk on. So eventually, when we walk off the edge, we're going to fall down, but instead of just allowing us to walk down here, we're actually going to reset the game you lose if you hit the bottom of the floor. So if we go back to do, we can check off number 8. We added in image platforms. That's going to bring us to number 9, which is going to be parallax scroll, in which we're actually going to be adding in more images to make it look like the background is moving at a different speed than our foreground. It's going to create for a really cool effect. So inside of my downloads folder, I added in 2 new images. I added in a background for our game, and I added in a bunch of hills, which are just all one image, to help our game's performance a little bit. But these are going to be the images we want to take, copy, and then paste in to our newly created Mario game server images directly. So right next to our platform, we're going to paste these in, and now we can access our background and hills within our game. So these files are going to be available within the download link in the description in case you need them. But now at the very top of our file, we can import a few more images. So I'm just going to go ahead and copy this first import statement, paste it twice. And now I don't want to reference a platform. I want to reference hills from image/hills.png. And I want to do the same thing for our background. I'm just going to go ahead and change platform to not black, but background. And then we don't really need to console log this out because we can trust that this is being referenced from the correct location. Go ahead and save hills, background. Check our console. No errors there, so we did import these correctly. And now we can go ahead and add these into our game. Now the thing is, these aren't really platforms in which we should jump on, and these aren't really players either. Those are the only 2 classes that we have for any objects within our game. So what we need to do is we need to create a new class specifically for things such as decoration objects. I'm actually going to copy our class of platform right beneath it, paste it in, and I'm going to call this generic object. This is a class for a generic object, which doesn't really serve any purpose for our game, but scenery. So I'm going to call it that. Everything looks to be in shape right here. We don't really need to change much. Technically, we could use the exact same thing for our platforms, but then users would be able to jump on top of these generic objects because remember, our platforms have collision detection code within our animation loop. So that is why we're creating this new class rather than adding these into a platform class. So now that we have a generic object class, we can begin creating a constant called generic objects, just like we did with our platforms. It's going to be equal to an array. We can create a new generic object. Takes all the same arguments as our platform, so just an object. We need an x. What is our x going to be equal to? Let's just go ahead and start with our background. It's going to be equal to 0 because we want it to start on the very left-hand side of our screen, take up the whole thing. Our y is going to be equal to 0, top left-hand side of the screen. And then we need an image associated with our generic object. So this is now our issue, is we only have one image created in this one image constant, and it works for our platforms because they all share the same image. But once we need a second HTML image object, things kind of get a little messy. We can't reference the exact same image constant we had before. We need to create a new one, and it gets really tedious to be writing this kind of code over and over again just for different images. So it kind of makes sense to put this inside of a function and then use that function to provide us that image with a different source and an actual different image object. So what I'm going to do is I'm going to create a function called createImage, and I'm going to put this code inside of it. And then I'm going to return the image we are creating. So whenever we use this function, we're going to want to pass through what? We're going to want to pass through some sort of image. So my argument is going to be called image source, image src, and this image source is just going to be what we are importing at the very top. So platform, hills, and background, these are actually image sources, so we're just going to be passing these through into our create image function. But now we need to actually create some images. So I'm going to go ahead and create an image right here. I'm going to set image equal to create image. What image do I want to create? Well, I want to reference our platform image. And then I want to do the same thing for the second platform, like so. So now if I save and refresh, still an issue right here because we can no longer reference just this one image constant. It doesn't exist anymore. Let's just go ahead and create an image with our platform. Well, not our platform because we already have everything set up, but with our background instead. So I save. And then I look inside of here, and we're getting the issue image is not defined, so image is still being referenced somewhere, and it was going to be right here. So what I could do is I could create a third image and reference our image width like so, but that is a little tedious. We're already creating an image in 2 locations. It kind of makes it very annoying to create it in 3. So instead I can create a constant called platform image like so, set it equal to what we just created with that platform image URL. Now I can reference this one constant right here for our platform image. Also reference it right here, so we're just using the same image, same HTML image we just created, and now I can reference our platform image width instead. So it's not that much less code than what we had previously, but we don't have to keep creating a new image and referencing the source object. Once we do this over and over again over time, this would get really tedious, so it does make more sense to create this one constant with create image instead. So now if I refresh, exit out of this, our platform is in place, but we are currently missing our background right here. Why is the background not showing? Well, it's because we're not actually rendering our generic objects out on the screen. So we need to select all of our generic objects, go to our platforms where we're drawing each. We know that our generic objects should be in the far background, so they're going to be the very first thing we reference. Reference generic objects like so. We're going to loop through each of these generic objects. So grab one generic object at a time, create an arrow function. What do we want to do? Well, our generic objects have a draw function associated with them, as we can see right here, and this draws out each object. So just by saving and refreshing, now we have an image being drawn on the screen, but it is our platform image. It is not the background that we want. So what's going on here? Let's go ahead and check. So we're referencing a generic object, which creates an image with background. That seems to be in place. I don't really have an issue with that, but it seems like we are drawing our platform instead of our background because right here for image.source within our create image function, we are referencing the platform URL. We don't want to reference that. We want to reference image source that we are passing through. So platform for the platform image and then background for the background image. On save and refresh, now our background is in place. Everything's looking quite nice, but we do have these little white edges on the left and the top hand side of the screen. To get rid of those, we can just change the X location of our generic object to be -1, same for Y, and that's going to get rid of those white edges. So now we have a nice background in place. Our character moves. The platform moves, but our background stays in place because that is currently what we told it to do. It's not actually moving, which is totally fine for the time being. So let's go ahead and add our hills in here as well. To add in hills, all we need to do is create a new generic object right beneath where we created our background object. And now we can say we want to create an image from our hills. And that's all we have to do to get them in place. So remember, this is just one large file that I exported from an Illustrator file that I created. And I put all these hills in a specific location in which I thought they would look good. You'll see as I begin moving to the right, the hills stay in place. And this is fine. This is totally okay for your game if that's what you want. But it does make more sense for the background to move, especially the hills, to create that parallax effect and to show that your player is actually moving. So to create that parallax effect, we're going to focus in on where we are moving our platforms. We're not just going to move our platforms, we're also going to be moving what? Our generic objects. We're going to loop through and grab each generic object within our generic objects array, create an arrow function based off of that, and I want to say for each generic object within this array, I want to move it by a value of 3. So if we were to set this equal to 5 to start, save and refresh, you're going to see, well, things aren't working. I have some sort of code error. It's going to be right here. I'm selecting our generic object, but I'm not actually referencing the position on the x-axis. We want to make sure we're specific with that. Now if I begin moving to the right, everything moves at the exact same speed, which could be what you're going for. We need to make sure we add the code for going to the left as well. This could be what you're going for, but it doesn't make your game look as professional or as realistic as it could be. Instead of moving this by something like 5, the same speed in which we're moving everything else, if we move this to a smaller value, such as 3, meaning it's going to move slower, watch what happens. We create a nice parallax scroll in which the background moves at a different speed than the actual foreground. So we're not going to see any movement right now when we're going back because we haven't set that up. But if I copy this generic objects for each code, put it in the left pressed key section, and then instead of subtracting 3, I'm going to add 3. We should get movement in each direction. So if I go to the right, we get that parallax effect, really nice. And if I go to the left, that parallax effect works in reverse. And eventually we're going to go off the screen. I'll show you how to fix this soon enough. but that is going to be how we add parallax effect into our game to create that really nice movement. So you'll see eventually when I go to the right, I put more hills into this image, and you can keep going further and further to the right to see more of these hills. Eventually it's going to end, but that is how you're going to be adding in additional background element for your game. So if we go to do, and check off parallax scroll. So next up, we're going to be creating the dreaded death pit. What is a death pit? Well, it's going to be just a simple pit that we have to jump over to survive, to not die in the game. So the first thing we need to do is create some sort of gap to jump over. We can do this by creating an additional platform where we are currently creating our current 2 platforms. What I'm going to do is I'm going to take one of these platforms we already created, add a comma to the end of it, and then I'm going to paste in an additional platform. But we need to make sure that we set this platform to have a different location than what we have right now. So we can keep all of this as is, but if we want to make sure this platform is moved over to the right by 1 additional platform compared to what we have right now, we could just multiply our platform width by 2. And that should create a very long platform for us to go over. And as you see, this is our 3rd platform. We have a little bit of a gap that we could get rid of by subtracting something like 4 instead of 3. But we want to make sure this gap is more apparent than just 1 pixel. So we want to make sure that we're adding on space to our X position to create some sort of gap to jump over. So once I add on 100, like you saw right there, we now have a small gap to jump over. Nice little baby gap to get people used to our game. So I can jump over that. We're good to go. We survived. But if I were to fall into this, well, that is supposed to be the end of the game. So what we need to do is we need to make sure that our player's Y velocity is no longer equal to 0 when we hit the bottom of the screen. Where are we setting our player's Y velocity equal to 0? It's going to be up here within our player class. Remember, we created this code for gravity that says if our player's position is greater than or equal to our canvas height, then we're going to be setting our player's velocity y equal to 0. We no longer need this code because we want our player to keep falling if they hit or go past this point on the bottom of the screen. All the platforms are still in place because we have that collision detection code, which is going to keep our player on top of them, but it's definitely fine to remove the code right here that keeps our player in place on the bottom of the screen. So just by saving that, after deleting that 1 line of code, let's watch what happens. We keep on moving, and eventually we fall down. Our player is no longer on the screen, we can no longer play the game, but once our player falls off the screen, we want to reset the game from the very beginning. There's no point of playing a game in which we can't actually come back and start playing once more. So how do we actually reset this game? Well, whenever our player falls, we need to make sure we're calling all this initialization code over again. It's going to be a little tedious, but I promise you it's not that hard to restart things. So right here in our animation loop, we have our win condition. We're also going to be adding in a lose condition. And we're going to say if our player's dot position on the y-axis is greater than canvas dot height, meaning the very top of our player is below the canvas height right here off the screen. Then we're going to console log you lose. Okay, so if we open up our console like so, I'm actually going to shift this over to the right so we can see things a bit better. It's maybe not the greatest. Move this over to the right a bit more. If I start going, you'll see eventually when I fall in the hole, we get the condition you lose only because I fell in that hole. You'll see it doesn't appear when I actually jump over it. But now if we fall down again, well, we lose once more. So here is where we're going to want to restart our game. So what I can do is I'm going to call a function called init, which is just going to reset all of our player stats so the game restarts. So where are we setting our player stats initially? It's going to be right here. You'll see we're setting everything. This is where we're going to want to create a function called init. We're just going to wrap everything we have right now inside of this init function. So you'll see everything is wrapped, but we're going to be getting a bunch of bugs because none of these constants are available to us anymore because they're wrapped inside of this init function. So we can keep things as is right here, but we're going to want to copy everything and paste it outside of the init function just to start. And then inside of the init function, we're going to want to get rid of all of the constants because we want to make sure that we're resetting each of these constants equal to the values they were initially set at. So I can go ahead, delete the constants for every single one of these objects. Actually, we don't even really need to reset our keys because these are always going to remain changing by the event listener. So we can go ahead and get rid of that within our init function. We can go ahead and get rid of our let as well. We don't need that. And things might be functioning right now, but we're going to get a bug when we actually reset our game, because since these are equal to constants up above, that means they are not changeable even when we call init. So we need to change our constant to let, which is going to allow us to change the values of these actual variables. So we're going to go ahead and change all of our constants in which we're changing things equal to let. We can keep keys the same, that is fine. Let is already assigned. Scroll offset is already a let, we are good there. So now, when we die in our game by falling down the hole, we reset everything because we are calling init, which resets all of our initial values. And you'll see right here, based on this lose condition, we are just simply calling init. So that is how we're going to create death pits, in which we can actually restart our game once we lose. Pretty cool. So if we go back to do, we're going to go ahead and check off death pits. So now we have pretty much everything we need in place to begin a full level creation. So right now, our game is pretty dull. All we have to do is jump over one tiny little gap, and then we reach the end. Pretty boring. So we want to make sure that we're creating more platforms, and we might even want to speed up our player a little bit to make sure that we're able to test this game in an efficient manner. So first, let's just go ahead and speed up our player before we actually begin testing things. What I'm going to do here to speed up our player is each of these 5s represents our player's speed. It's not very descriptive, and it's not easy to change because we need to change this 5 in multiple locations. So instead of referencing just a static value, I'm going to reference our player's speed instead for each place in which we are setting something equal to 5. So player.speed, player.speed, player.speed for here. And then we have one right here that I missed. We have a few locations in which the speed is equal to 3. We want to make this 3 be determined based off some sort of ratio on our player's speed. So let's just go ahead and say we want this to be about 66% of our player speed for all of our generic objects to make sure they are moving at a slower pace to give that parallax effect. But now we actually need to assign our player some sort of speed property. So if I go ahead and find our player class, I can now add in this dot speed, set it equal to, let's say 10, so double of what we had previously. And now our player and the background objects should be moving a lot quicker compared to before. It's a lot easier to test. Let's go ahead and keep this as is for now. We might even want to set our player's Y velocity when we jump to be something smaller. Right now it's super ridiculous how high our player can jump. Let's go ahead and decrease that. That is going to be within our event listener on, I believe, key down. And right here, we're setting our player's velocity equal to -20. Let's go ahead and set it equal to 10. See what that looks like. And I think that is a good amount for our player to jump, at least for the time being. So now let's begin adding on platforms to make this game a little more enjoyable. We're going to go to where we created our current platforms, and we're just going to simply copy and paste to create a new platform. So now we know we want this platform to be a little bit further than the platform we had previously. So this is our previous code. We can simply multiply our platform image width by 3, add on 100 and see what that looks like. We're going to go to the right. And you're going to see, well, we have an issue with our platform not actually showing. And that's because I actually added in this new platform within our init function, which is only called on reset. So really, this should be called a reset instead of init, but it is a little annoying to have to be able to create this in multiple places. So instead of creating all of our objects on initial load and then separately whenever we restart our game, I'm going to go ahead and on initial load, say that there should be no objects created, at least not yet. We can go ahead and keep player there the same. And now we're only going to create these projects when we call init. So we also want to call init whenever we start our game. So right above animate, I'm going to call init. And now init is going to be called on initial load, initialization, and it's also going to be called whenever we restart our game. So you'll see all of our objects are in place still because we just called init. We have our gap, and then we have an additional platform added on because now we're just calling our init code to pre-populate our platforms. So you'll see we might want to add a little bit of a gap here, maybe something a little larger than 100. So go ahead and add on 200 instead. Actually 300, because that is going to be the difference between the last x value. If I go ahead, do that, now we have a little bit more of a gap jump across. So making our game a bit harder, we might want to add a longer platform to the last location. So I'm going to add in a new platform, multiply this by 4, because We want to make sure that this is in the correct location. So now if I go, we jump the first one, jump the second, and now we have a platform added on. We still have this little annoying gap right here. All we have to do is subtract 1 or 2. Should make things look like they're all 1, which they are. So now we have this larger gap. And now let's go ahead and just say we want a super far jump at the very end there, but we need some sort of platform above it in order to obtain that jump. So what I'm going to do here is add in one additional image, which will be available in the link. It's going to be platform small, tall. So it's short, small, but it's also going to be tall. We're going to want to jump on top of this in order to get our desired location. So I'm going to go ahead and drag that into our game directory like so. And once we drag that in, we need to import it into our project. So I'm going to copy and paste this import statement. Say we want to import platform small, tall from /img platform small, tall. Now that I have this imported, we have the URL. We just need to go ahead and create the image. And this is going to be a platform, so I'm going to go ahead and copy the last platform we had. But I'm not going to reference the platform image we have been referencing. I'm going to reference a new create image, which is going to be platform small, tall. So now once we do that, we should see a taller platform around that same location. And maybe we don't at the moment, that's okay. It's simply because our Y value is the same. It's pushing the tall platform to the exact same position as current platform. So all we need to do is subtract this to make sure that it's not pushed as far down. You can jump once more. And now this is in almost the correct location. So you'll see our platform is indeed in the game. We can jump on top of it. And now we can get that extra jump that we might have wanted. But one issue is this platform is being drawn in the front when it should be drawn in the back of the old platforms. To get the draw location correct, we just need to make sure that this platform, small, tall platform, is the very first thing within our platforms array. By doing that, we make sure we draw this first. And it's going to be drawn in the background compared to everything else, and it looks really nice as a result. We might want to move this over a little bit, so we need to make sure we are affecting the X location of this platform to be moved over. So if we want this drawn at the end, we want to make sure we're adding on our platform image width once more. That's going to push it to the very end. We might not even need the plus 300, we'll see. We're going to go to the very end. This is why we increase the speed to make sure things go quickly. And you'll see it is indeed placed at the very end, but if we want it placed over here, what are we going to have to do? We're going to have to subtract the width of this current image we're creating. So instead of use create image once more, we can just go ahead and assign this to a constant, similarly to like we did for our platform image originally. I'm going to call this platform small, tall image, and add that create image code for our platform small, tall. So now if I copy this, all I need to do for our width is subtract the width of this one image right here, and that should put it in the exact location we want. So now if I keep going, I jump once more, and that is indeed in the correct location. Can jump on top of that, and now we have a higher platform in which we can try to jump somewhere further. So we need to add one more platform onto this. I'm going to add one more platform. I'm just going to multiply this by 5, maybe. Let's just keep things as 5 for now. I'm going to call this plus 600 to add on to the current 300 we had previously. And let's see how big of a gap that is. We're going to fine tune this to our needs. Jump on the top. Let's see if we can jump this being on the bottom. Looks like we can, so we want to make this a little further to make this more challenging. Let's try 700. It's going to refresh. And we'll do it one more time. So we jump, and that's definitely too far. I tried cheating the game because you can always press up multiple times if you want. That is something you can take out of the game with a bit of extra code. If I go up, and I try jumping this, and when I press up, you'll see it's a little inconsistent with my jumping speed, so something's a little off here. You'll see if I go back down to our add event listeners, when I hit key down, we're setting our player's Y velocity to -10, but we also have this code on key up for some reason. I think I just forgot to delete it when I was showing some things off. So we want to make sure that we delete that from key up. We don't want our velocity affected when we release our up key. So now, when I jump, you'll see that is just way too low of a jump, and it was definitely being affected by our key up over here. So now we can increase the velocity, maybe go back to 30 where we were. I think that was a good location. And that is definitely a big jump. Maybe we'll try 25, make it a little lower. And that seems to be pretty good for me. So now our jumping is a little more in tune with where it should be. We can definitely jump on top of this, which is great. But like you see, there's no way we're going to make that jump without jumping on the top platform. So we go back, jump on the top platform. Now we can make that jump, makes our game a little harder. And now over here is where we should be ending the game. So once we reach this platform, we want to end the game. And in order to get this location in which we should end the game, we just want to find the very last platform, get the X value, so this right here. And all I'm going to do is, where we are ending our game, say if our scroll offset is greater than this position in which our platform is placed, then we win. So let's test that out. We move to the right, jump that, jump again, jump on the top one, jump the last one. And now right about here is where we're actually winning. So things are going to be a little off, around 400 pixels off, because our platforms only start scrolling when our player is at 400 pixels. So what we could do is we could just subtract 400 from this statement right here, or we could set our scroll offset equal to 400 to start. It doesn't really matter. As long as this works, we should be fine. We try jumping again, and now whenever we're on this platform, we get you win. So that is how we're going to be finishing up our game, at least for the level creation. I definitely encourage you to keep on going, create as many platforms as you want, as many jumps as you want, because I provided this image to basically go on for almost about a good amount of time, almost like 10 times the amount that I just created levels for. It's just going to be tedious to create the whole thing, but you can see I placed mountains, hills in different locations, and eventually once we go to the very end of this, we're just going to hit white. This is where you should be ending your game. Once we hit white, eventually we're going to end the game. This is where you should definitely end your game if you hit white. Eventually our player is going to fall. You'll see him soon, I hope. It should restart the game. But for now, that is going to be good for tutorial purposes. So if I open up our to-dos, we created a level, and now we're going to move on to fine-tuning. We already did a little bit of fine-tuning, but there's still one thing I want to take into consideration. That is going to be, when we hit the left side of the screen, we should not be able to go off the side like this. This just looks unprofessional and kind of dumb. There's no really purpose of including that. So where we are currently moving our player, it's going to be within this else-if statement within our animation loop. We're actually going to want to wrap what we have currently inside of parentheses because we're going to be adding in an or statement at the end of this. And this or statement is going to say if our keys left dot pressed is true. So if we are still pressing our left key and our scroll offset is equal to 0, meaning we haven't actually moved anywhere on our stage, and our player dot position dot x is greater than 0. We still want to be able to move our player to the left, but we're no longer going to be able to move our player if the player hits the left-hand side of the screen and tries to go any further. We're just going to go into our else statement instead, which calls the following code. So let's go ahead and save that just to see what happens. And you might need to wrap all that in a second set of parentheses. You'll see it was done automatically for me. Now this will allow our player to move further to the left-hand side of the screen without being restricted to that 100 over here since we're still at the beginning. But if I still try going further to the left, you'll see we fall off. We need to go ahead and set our else-if statement for all of our platforms to say that we only want to move our platforms to the right if our scroll offset is greater than 0. So since we start out at 0 and we go to the left, we're not moving anything, we can no longer scroll everything no matter how hard I try to go to the left. I can jump, we're not going to be moving. But if I go to the right, everything works as expected. And if I go back to the left, everything goes back to moving correctly. And I can't go past the beginning because we just added those 2 additional conditionals. So that is how we are going to fine-tune our game. Everything works pretty well. The very last thing I want to do, which I actually did not include on this list, is going to be no other than 13 sprite creation. What is a sprite? Well, it's going to be this little character right here that moves and jumps as you go throughout your game. This obviously adds a lot more liveliness compared to just a square over here. You can call your game complete with just a square, it doesn't really matter to me. But if you want to go ahead and take it to the next level with some sort of character, I'm going to show you how to do it. Now note, everything up until this point you can use completely free, but this one character that I'm going to show you how to do this with, I got this from a tool called the DK tool. It's an After Effects tool in which you can get a free trial if you want to go ahead and download this character yourself. All I did was I generated this character from the tool. It's from a popular artist called DK Kwan, I believe his name is. And from that tool, from that one preset he provided, I created all these animations on my own. So I will provide the sprite sheet in which we need to create these animations, but just note, if you're going to be using this on some sort of commercial project, probably not the best idea because I got this from a tool I bought, and although there is a trial in which you can get this from free, I'm sure there's some sort of licensing involved with it. So it's probably a better idea to create your own character with your own animations and sprite sheets. But I will provide the sprite sheet for you for personal use, just so you can see exactly how these animations are created and how you can insert them into your game. So to swap out our square with an actual character, here is what we're going to want to do. Well, first, you'll see I added 4 new files into this untitled folder, which we're going to be dragging into our project. So these files are sprite sheets. If we open one of these up to preview it, you'll see that this is just one really long image containing all of the movements for a full cycle of animation within our character. I animated this using the DK tool, and I outputted all the results using a tool with Windows. I think it was called Glue It. And you can go ahead and check out a little more on how I created this with the Coding Super Mario that is in Super Mario video that I made with this link. But you'll see this is all a sprite sheet is, and the reason we use sprite sheets is so that we don't have to load all these images at one time and then cycle between all those images. We only load one image, and then we crop the image to only show one of our characters at a time, and then we swipe through the whole thing to create that animation effect for performance reasons. So let me explain and show you how this works a little better. So we're going to go ahead and copy these 4 sprite sheets, sprite run left, sprite run right, sprite stand left, and sprite stand right. We're going to copy these into our project's image folder, just like we did for everything else. And now we can go into our project and we can begin importing these sprite sheets. So I'm going to go ahead and copy platform small tall, this line of code 4 times. And then I'm going to begin replacing these with what we just imported over here. So the first one is sprite run left, sprite run left. Make sure you spell that correctly. The next one is going to be sprite run right. What is next? We have sprite stand left, sprite stand left, and then we have sprite stand right, sprite stand right. So this imports all of our sprite sheets. And now we're going to go ahead and start with sprite stand right, because that is going to be the default animation in which our character just stands facing the right hand side while bobbing up and down. So what determines what our player looks like? Well, this draw method right here within our player class. We no longer want our player to be a simple rectangle, so we're going to delete this code. We want our player to be an image. So it's kind of hard to remember the arguments for c.drawImage, so it makes sense to go to our platform class, copy the c.drawImage here because it's going to be exactly the same to start, and then paste it within our player draw method like so. So that's going to refresh, and we're no longer going to see our player because we don't have an image associated with our player. So we're going to add an image property, this.image, and set it equal to no other than create image. What image do we want to create from? It's going to be our sprite stand right. So now we have our image and put it in the game. And you'll see I exported this image a little bigger than it probably should have been. It's taking up the whole screen, but that's not a problem because we can fix that with our draw image function. So to set this up for sprite sheet usage where we can swipe between all of these images, we're going to want to add in 2 more arguments to the end of c.drawImage. The 4th one, I believe it is the 4th one, yep, the 4th argument we're going to be adding in here is going to be the width we want our character to be. And then the 4th one, 5th one maybe, I forget which one, is going to be the height that we want our character to be. So you'll see with this, if we look really closely, this is going to be the width and height of our character based on the image we imported. So this is obviously way too small. So I'm going to go ahead and increase our height to something like 150, and I already did a little bit of math to make sure that this shows at the right dimension on the screen for our width. I'm going to go ahead and put 66. So you'll see this box right here is going to represent how big our character is. Right now our entire image is just smushed so small together that it looks like complete garbage. But that is okay because we're going to extend this draw image function to crop a portion of this image so it only shows one of our characters at a time. So It's a little confusing with how c.drawImage works. Unfortunately, the API is not the greatest on this one function, but nevertheless, let me show you how to begin cropping. So if you want to go ahead and begin cropping this image, you're going to have to push these 4 arguments down, and we're going to be adding 4 more before it. So the first one we're going to be adding is where from the original image do we want to begin cropping from? What position? Well, we know we want to crop from the top left-hand corner. So our x is going to be equal to 0, our y, which is the next argument, is going to be equal to 0. We're going to crop from the top left-hand corner of our image, and then we want to specify to what width of the original image do we want to crop to. So if we were to look within Finder, Sprite, stand right, what is the width of this image? It's going to be 10,620. But if you were to measure out one of these characters individually, the width would be 177. So we are going to go ahead and say that the crop width of the original image should be 177. Now, what should the crop height be of the original image? We can simply go ahead and look at the height. This is going to be 400 of the original. Add a comma after that. And now you'll see our image is perfectly cropped, so we're only showing just one section of our character. Now that we have drawImage set up like this, we can begin looping through all the different images within this one sprite sheet. So here's how we're going to do it. Within our player class, in our constructor, we're going to go ahead and add another property called frames, and this is going to be equal to 0 to start. This is going to represent what frame are we currently on within our animation over here. So obviously we want to start off on the first frame, which is going to be 0. And we want to say right here, 177, where we determine what width should we be cropping at from the original image. We're going to multiply this by this dot frames. So if you think about this, to start, on the very first frame, this dot frames is going to be equal to 0. So we multiply 177 by 0. We're going to get no other than 0. But if we begin to increase this dot frames over time, eventually we're going to get 177. And if we get 177, and we start cropping from 177 pixels from the left, we are going to go to this version of the image. And then as we begin multiplying this dot frames by an increasing frame rate, we're going to keep pushing our crop mark to the side, and we're eventually going to loop through all these images till we get to the end and we tell our frames to go back to 0. So where would we increase this dot frames over time? It's going to be within our update function, and it can be the very first thing that we do. So we're going to say this dot frames is going to increase by 1 over time. So let's watch what happens. We save that and refresh, and we have an obvious issue here where we're looping through something and eventually our character is just going to go off the screen completely. So this is looping through all of our frames so quickly, and it's increasing this number right here to something that doesn't even make sense. It's pretty much pushing our crop mark off of the image, and it's creating this really weird effect. So we want to make sure whenever we reach the very last frame, the very last section of our image, we want to reset our frames equal to 0. So what we can say is if this dot frames is greater than 28, because I believe when I counted, this was 28 characters within this one sprite sheet. So whenever we go through 28 frames of our character, what do we want to do? Let me exit out of these real quick. What do we want to do? We want to set our frames to 0. We're going to go back to the beginning and reset the loop. And so obviously this is not correct, and this is a little bit of a misdeed on my part. So you'll see right here, I'm actually multiplying the width right now, so I'm changing the width of the crop mark. That is my mistake. We actually want to multiply the original position in which we're cropping from, so the X position. This should by default be equal to 177, because remember, when we multiply this dot frames by 177 to start, this dot frames is a 0. So this equation is equal to 0, and then once we begin multiplying it, that is when we begin moving that crop mark across our entire sprite sheet. So if we go ahead and move this to our X coordinate of where we're cropping everything, you're going to see now we have an animated character that is bobbing up and down just like we want. And we can begin playing the game just like this. It doesn't look that realistic, but it does look better compared to that little square that we had before. So let's say we want to change this sprite sheet if a character is running compared to when our character is standing. In order to do this, we need to make sure that we're importing a running sprite sheet. And what do you know? One of those images that we imported was a running sprite sheet. So here, what I'm going to do is I'm going to add an additional property into our player constructor that says this dot sprites. This is going to be equal to an object, and here I'm going to start defining the sprites associated with each action our character takes. So one of these actions is going to be stand, and this is going to be equal to an object because we're going to have a sprite sheet for standing to the right and a different sprite sheet for standing to the left. So we can say our stand right sprite sheet is going to be equal to this one image right here that we assigned to this dot image. We can go ahead and keep this dot image for the time being, but we're also going to have a run sprite, and this is going to be equal to right. And then we need to create an image from our run right sprite sheet, which we already imported. So we can reference sprite run right like so. So now our sprite sheet is associated with this object right here, and we can begin interchanging the sprite stand right and the sprite run right properties. So this is going to take place within the c.draw image function right here. We're going to need one sprite sheet that is current, whatever is being ran within the draw image right here. So I'm going to create one more property called current sprite, and this is going to be equal to, by default, this dot sprite run. Well, not run right, but actually stand right by default. And now we can say c.drawImage is going to draw by default this dot current sprite. So whenever we begin running, we're going to want to swap this dot current sprite out with not sprite stand right, but sprite run right. How do we do that? Well, now that we have all of this set up, where are we actually determining when our player is running to the right? Well, it kind of makes sense to look for our event listener, where we are listening for our key down event. So right here, we're saying that our keys right.pressed is equal to true, but what happens if we say our player.current sprite is going to be equal to our player's sprites run.right sprite instead? Let's go ahead and watch what happens. So we begin running, and you'll see we have some sort of running animation in place. Now there's a few issues here with this. One is we can't go back to the original animation, and two, this running animation doesn't actually work because it is a little larger in width compared to the standing animation that we had previously. So to fix this, we're going to want to go back to our player class, and we're going to want to focus on this 177 value right here. So this is the crop width associated with the standing image. This is how large it is, but we're going to have a different width for running because simply I made the running animation a bit larger. You probably shouldn't do that when you're actually developing these animations, but unfortunately I did. So we're going to have to accommodate for that. So within these sprites objects, I'm going to go ahead and add in a property for crop width. And we know standing is going to be 177. That's what's there currently, but we're going to have a different one for running. This is going to be 340, almost twice as big. My bad. So now we want to make sure that this value right here, 177 and 177, references this dot current crop width, whatever that may be. So by default, I'm going to say this dot current crop width is equal to 177. Basically whatever is right here to start, doesn't really matter if we go ahead and reference this directly or just say that it's equal to 177. So things work originally, but now whenever we hit right on our keyboard, so all the way down here at the bottom, right here on the key down event, we want to say our player current sprite is going to be equal to this, but our player dot current crop width is also equal to the crop width associated with our run. So run dot crop width. So let's watch what happens. We begin running, and now we almost have something that looks correct. We just have a minified version of our character. It looks kind of silly. We're almost there, so let's go ahead and fix this. So to get this looking like the correct width of the image, we're going to need to go back to our player class, and we're going to be adding in one more property associated with our sprites. This is going to be just simply width. What should the width be of the actual small version of our image? Well, I can tell you right now, for running, this width should be, let's go to running, this width should be 127.875. This is going to be the exact ratio we need to be coupled with this dot height to get the correct dimensions showing. But we're also going to need a width associated with our standing sprite to go back to this over here. So our original width for standing is 66. We're going to go ahead and put that there. These can go ahead and stay the same for defaults because we're going to be changing them as we begin to move stuff. So now, back in our event listener, right here, we're also going to change our current, well, not our width, but our player width, that's going to be the current width essentially, to the width of the run animation. So now when we do this, we should have things working, which if we begin running, now we have a working running animation. But there is something off about this. You'll notice it looks a little jank. It's not as smooth as it should be. The reason for this is this running animation has more frames in it compared to the standing animation. The standing animation has about 28 frames, which we specified right here, but the running animation has around 59 to 60. I can't remember which I put it at, but we're going to find out. So up here, we only want to reset the frames to 0 if this.frames is greater than 28, and what if this dot current sprite is equal to the standing sprite. So we have our current sprite up here, and by default it's equal to this. We want to make sure we're testing for this within our code. We're only going to go back to 0 if this is true. Otherwise, what's going to happen? Well, we're going to basically go out of the frame rate. It's not going to reset to 0 like we need it to for the running animation, but that's simple enough. We can just go ahead and add an else if to the end of this that says if our frames are greater than 60, and our current sprite is equal to this sprite's not stand but run right instead, then we also want to reset this dot frames to 0. So now if we begin running, you'll see it almost looks correct, but at the very end of this animation we are cutting it off completely, probably because this frame rate is not correct. Let's go ahead and change it to, well, not 49 but rather 59 to see if we can get this working. And you'll see still a little bit of jankiness. I might have actually had these frames wrong to begin with. So let's go ahead and say if frames is greater than 29, we want to reset it. Eventually we should see some sort of gap in between. That's looking pretty good. Let's go ahead and change this to 30 just to test this out. You can also just count the amount of sprites in your sprite sheet, but I'm a little too lazy for that, so I'm just going to test. You'll see there's definitely a little bit of a gap there. So the correct frame rate for running is 29, which means for standing, the correct frame rate is probably what I thought it was for running, which is going to be 59. Let's go ahead and see if that works. And then indeed it looks really good. There's no gap or anything. So this is actually the 60 frame rate for standing, and the running one is actually around 29, 30 frames. So that looks not bad. But you'll see there's just still something not right with it. We have a little bit of our player showing over here, so we want to be exact with our actual crop width. Let's go ahead and increase this by 1. Might be a little off there. Let's test it out. And that looks probably about as perfect as we're going to get with toggling between running and standing. So you'll see that looks pretty good. It's very smooth. Creates the illusion of running for sure. But now when we stop, we don't actually go back to our standing position. So to fix this, we can go back to our event listeners where we are declaring all of this right here. We can go ahead and grab these 3 and then say whenever our right key is released, whenever we key up, we want to go back to not run for each of these, but stand instead. So we begin running, then we stop, we stand. Begin running again, and then we stand. So that is exactly how you're going to toggle between the two. And you might notice that our character, when we begin to stand, it goes back a little bit. That is simply because the width of our character is changing because I did these animations wrong. They should be around the same width, but unfortunately I'm not the best designer or animator, so I didn't know that before I made them. So let's go ahead and add the sprite sheets for moving backwards, and we should be able to call this initial tutorial complete. So I think you can kind of guess how to do this. We're just going to go ahead and focus in on the left key right here. So we're going to copy these 3 lines of code, and then when we press down on left, what do we want to do? We want to go ahead and set our sprite to run, not to the right, but rather to the left. And we can go ahead and keep these 2 the same because we're going to have the same width for our running animation even though we're going to the left. So now we just need to make sure that we have a sprite run left sprite in the first place. So if we go back up to our player class right here, we have stand right, but we also want a stand left. And now we need to make sure we're creating an image from player sprite stand left like so. And we're going to go ahead and add one in for run as well. So sprite 1, 2, 3, 4, 5, run left. And now we have these in place and we can begin toggling between them as needed. So with these in place, you'll see if I begin going to the left, no animation, and that is because we didn't say down here within our update frame section whether or not the current sprite can either be stand left or run left. So let's go ahead and focus on our running first. We're going to say if our frames is greater than 29 and this sprite is equal to sprites run right, or this dot current sprite is equal to this dot sprites run left. And then close off that additional statement. So now this should be working when we run to the left, which it kind of is. We seem to be having some issue with toggling between standing and running to the left, which we will fix. But before we actually fix that, let's go ahead and add the additional conditional to our standing statement like so. We're going to say if this dot current sprite is equal to this dot sprites stand left. Then we want to reset our frames equal to 0 when our frames go above 59. So we have these new conditionals in place, but you'll see we can't transition between the different sprites smoothly. It just ends up messing up in some sort of way, and this really has to do with the key up function right here. We might be pressing down A while we hold down D, and then release, or release at a certain time as we're holding down both. So to go back to standing, key up really isn't going to cut it. So we're going to want to go ahead and take out this code right here, and we're going to want to go ahead and switch between our sprites within our animation loop instead. So here, beneath our platforms, I'm going to go ahead and say if our current key is equal to right and our player dot current sprite is not equal to player dot sprites dot run dot right. So this is checking if we're in the standing state. Then what do we want to happen? We want to go ahead and change our player's current sprite equal to what? Our player dot sprites dot run dot right. We also want to go ahead and make sure that our player's frames is reset to 1, so the very beginning of our animation, to make sure that if we're about 58 frames into our standing animation, we don't go back into our running animation, which doesn't have a 58th frame. We're going to be restarting this from the beginning, so we're going to set it equal to 1. And now if we go ahead and get rid of this code right here, we're going to want to put this code inside of that conditional that we just created as well. So let's go ahead and focus on right. We're going to go ahead and cut this code so we can copy it later, but we're going to want to go ahead and say our current key is equal to right here. And the reason I'm not using key right pressed is because, like I said, we might be pressing down our left key before we actually lift up on the right one, so I don't want to use any of the key right press stuff. I'm going to create a new let at the very top near our keys right here called current key. This is going to be equal to nothing to start, doesn't really matter. And then I'm going to head back down to our sprite switching conditional, and I'm going to paste in what we just had within that switch case statement. So you'll see one of these is duplicative, but we're also going to be changing the current crop width and the width of our player as we begin to transition between things. So with this, we now have a perfect transition between standing and running initially. We had that earlier, but now this is going to allow us to go back to standing if we need to. So now we can write an else if that says if our current key is equal to left and the player's current sprite is not equal to player dot sprites dot run dot left. What do we want to do? We want to go ahead and get the code that sends our player to the left. So it's going to be this code right here. I'm going to cut it out of the switch case statement, but I'm also going to put in current key, set it equal to left to make sure we're able to go to the left. Make sure you spell key correctly, unlike me, current key to the left. And now with that code I just cut out, we'll put it inside of our new conditional, and that should transition us to the left when we press left. No problem. So that is going to fix the transitioning between running left and running to the right. Now all we need to do is make sure we go back to a standing position, whether it be standing to the left, standing to the right, whenever we stop. So it's a little tricky with the standing animation. We're going to have to change a little bit. So instead of calling this current key, I'm actually going to rename this everywhere by selecting the name and hitting Command D in Sublime Text to select all instances. I'm going to rename this last key because it makes a little more sense for what we're about to do. So this is going to be the last key that we are pressing down. So we're going to want to monitor the last key in case we go between left and right, A and D. But we're also going to want to monitor what key we're actually pressing down in this current moment, which we can get with our keys dot right, I believe this is the right, yep, dot pressed. So we're going to add this additional conditional to the first if statement. And then we're going to add the same thing to our else if statement that says if keys left is pressed is equal to this, then we're going to set it equal to everything we need to begin running to the left. You'll see this still functions as we need it to. But now we can go ahead and copy this else if statement, paste it in below, and we can say if the left key is not currently being pressed, but the last key was the left, meaning we lifted up on the left key, then we want to change our current sprite not to run, but rather stand. And we want to do the same exact thing for this run up here. So if we go ahead and save that, and we begin running to the left, and we lift up, now we're going to be standing to the left. So we want to do the exact same thing. We're going to add one more else if statement. It says if keys right is not being pressed down currently, and our last key was going to the right, we want our player to stand not to the left, but rather the right. So now if I begin running, I stop, we're standing, I go to the left, stop, stand, and now we have a fully functional sprite character in place to begin continuing our game. So from beginning to end, let's go ahead and admire the finished product. Can no longer go to the left. We coded all that. We have Parallax moving hills in the background. We have these jumps in which we can jump over. And then, if we can't make it, we just fall down and die. Pretty incredible. We keep on going. If we want to make this jump, finally we get to the end and we win. All these additional console logs, you can delete them if you'd like. You can keep them there to monitor which key you're pressing. It doesn't really matter, but that is going to be the end of this tutorial. So that's going to be it for this one, guys. If you would like to continue learning how to code Mario-like games, be sure to check out the premium tutorial in progress over on chriscourses.com. Here you can see I'm going to teach you how to create a block object, how to create Goombas, how to get a fire flower, which you can shoot different projectiles from. And we're going to be adding a lot more along the way. You'll see eventually when I get to the very end, if I can even make it. Well, we're going to add a death animation, multiple Goombas at the same time, jump kill effects, and then finally, well, I can't even get to the end, but I'm going to teach you guys how to slide on a pole and end the game. So I hope you guys are excited. Be sure to check it out if you're interested, and I hope you guys learned a lot with the tutorial that we just covered. So until next time, I'll see you guys in the next episode. Peace.